So good day and hello everyone. I'm Inhambre Princeton and we are the Group 3 reporting about how to carry out the following maintenance and what are the tools and materials to be used and what are the necessary precautions that should be carried prior, during and after maintenance in the piston overhaul of main propulsion engine and the piston overhaul of the diesel engine and taking crankshaft deflection for diesel engine and replacing a leaking mechanical seal of main engine lube oil pump. So first, I'm going to tackle about the piston overhaul of main propulsion. So these are the preparation in overhauling. So first, make sure the all standby auxiliary engines are ready. Number two, read the manual and have a toolbox meeting with everyone involved the job. Then discuss the complete procedure. Then prepare import tools and spares required for overhauling liner as a given in the manual. Number four, prepare risk assessment and make sure all the personal safety equipment are used. Five, go through the previous records and manual for clearance and adjustments. Six, put the display card when at work. Don't start at the lube oil pump and auxiliary engine breaker. Seven, close air bottle valve to auxiliary engine and the engine start and stop valve. 8. See that the turning bar is not in the flywheel and should be in the place. Number 9. Open the indicator cocks. 10. Close lube oil, fuel oil, fresh water inlet, and outlet valve. Then drain the cooling water line and remove connections. When drawing out the piston, cover the crankshaft with a sheet or the like to prevent water and foreign matters from entering the crankcase. So next is the safety precautions. So safety precautions before we start the overhaul, we must think first about safety word in order to get no one who will get hurt and it reduces injuries and cost. So these are the safety precautions. Next is we must wear a PPE for the word safety as I said earlier. Next is the pistons data and requirement tools. So these are the tools for overhauling. So piston overhauling procedures. So piston support. Place the piston support in the place the piston in the support and remove the piston lifting tool and clean the piston top and the piston rings. Check the free ring gap and the burn off on the piston top. Remove the stopping box. Next is the piston ring dismantling. Take off rings by means of the ring expanders, and if the engine is equipped with two ring expanders, the short ring expander is for the uppermost ring. First remove the uppermost ring and then ring number 2, 3, and 4. Then clean and inspect the rings and the ring groups. Next is the piston crown dismantling and loosen and remove the hydraulic nuts between the rod and the piston crown. Then lift the piston crown and skirt of the piston rod. Then cooling insert. Unscrew and remove the nuts and remove the cooling insert and clean and inspect it. Then piston rod and cooling pipe. So we must screw on the eye bolts and tilt out the cooling oil pipe. Clean and inspect the cooling oil pipe and the piston rod. Then reinsert the cooling pipe. Refit the cooling insert and tighten the nuts as specified in data. Check that the surfaces of the ring groove are clean and smooth. Fit a new ring of the piston rod flange. Next is the piston crown turning. Unhook the crane from the piston lifting tool and connect the lifting tool and the crane hook by means of a wire rope. Lift up the piston crown. Fit two eye bolts in the piston skirt and a wire rope between the bolts as shown in the sketch. Install a tackle in a suitable place with a sufficient space below for the piston crown. Attach the tackle to the wire rope on the piston skirt and carefully turn the piston crown upside down. Use both cranes if the engine room is equipped with two cranes. Land the piston, lifting tool and the piston crown on a sufficient support of wood pieces. Loosen the piston lifting tool and lift the piston crown clear of the tool. So next is the crown dismantling and cleaning. So place the piston crown with the skirt and the wooden support as shown, and then remove the locking wire and the screws in the skirt. If necessary, use dismantling screws to pull the skirt off the piston crown. Mount two eye bolts in the skirt and lift the skirt and land it on a couple of planks. Then discard the sealing ring on the piston skirt. Thoroughly clean and inspect all the parts of the crown and skirt. If coke deposits are on crown, the coke deposits should be washed out with a carbon remover or similar cleaning fluid. When all coke deposits have been dissolved, clean and inspect of the piston crown again. To note, coke deposits reduce the heat transfer of the piston crown to the cooling oil, so deposits must be removed as a routine procedure when a piston is overhauled. And if the piston crown is renewed, remove the piston crown studs using a stud setter. So, piston crown assemble. Mount the piston crown studs in a new overhauled piston crown. Lubricate the thread on the studs with molybdenum disulfide. Tighten the studs to the specified torque using a stud setter. Mount a new ring on the piston skirts. Check that the surfaces of the ring groove is clean and smooth. Coat the ring with lubricating oil before mounting. Mount the piston skirt on the piston crown and tighten the screws to the specified torque and lock the screws with locking wire. Then, piston crown and skirt mounting. Lubricate the ring on the piston rod flange with lubricating oil, and then land the overhauled piston crown and the skirt on the piston rod. Then mount and tighten the hydraulic nuts on the piston crown studs. When tightening the hydraulic nuts, follow the tightening sequence. All the nuts must be tightened twice to fully tightening pressure. Then the sealing ring and the pressure test. According must be pressure to current tested class rules. The piston hydraulically, it is possible to carry out a test of the sealing rings within the compressed air before filling the piston with oil. The sealing ring test can also be carried out when the piston is resting in the support tool. Mount the pressure testing tool on the piston rod foot. Connect compressed air to the testing tool and fill the piston to 4 to 5 bar, and then close the valve on the setting tool and remove the air connection. Then we must now hold the pressure for the minimum of 30 minutes and spray a little soap water on the surface joints between the piston rod, crown, or skirt and around the hydraulic nuts to detect the leaks and dry of all soap water. The next is the pressure test. For this test, the piston must be turned upside down. Then fill the piston and the piston rod with lubricating oil. Mount the pressure testing tool and the piston rod foot. Then pressure test the piston at the pressure stated on the data sheet. Then check the contact surfaces of the piston and the sealing rings for tightness. Check that there are no cracks in the piston crown. Then turn the piston upside and drain out the piston oil. Next is the piston turning. Lift the piston with the normal lifting tool and lower the piston rod foot until it is close to the platform, and then land the foot on the wooden block. Then lower the piston crown to the platform and land in the wooden block in such a way that is possible to remove. And after that, attach the lifting bracket to the bottom of the piston rod foot and hook the crane on the lifting bracket. So this is the piston turning. So the next is note during the lift, follow with the crane to keep the position vertically above the lifting point, and the stuffing box must be removed. In the completion, fit the new piston rings. So with the ring gaps staggered and with the top marked upwards using the ring expander. So do not expand the rings more than the necessary. The uppermost ring CPR ring must be mounted with a short ring expander. So that's all for my part. So the next reporter will be Engine Cadet Eroy.
Good day, everyone. I'm Engine Cadet Aero 0J, and For the day, I'm tasked to talk about the piston overhaul of diesel engine. So next slide, please. Next slide, please. So as you can see, the preparation in overhauling and safety precautions, PPE, piston data and requirements tools, piston data and requirements tools for overhauling is all the same as what in Humbree have been reported. So let's move on to piston overhauling procedures. So next slide, please. So as you can see, um, ease the piston down so that the stopping box is below the floor. Assemble the two halves of the piston support around the piston rod and land the piston on the support. Check and remove the piston rings. Dismount the locking wire and the innermost screws between the rod and the piston crown. Dismount the locking wire and screw up the support screws of the piston support to a position just below the piston skirt. Remove the piston skirt screws. Screw the four screws of the support downwards until the skirt rests on the support. If the skirt will not budge, free it by means of two dismounting screws. Lift away the piston crown. Remove and discard the sealing rings on the piston rod and on the skirt. Dismount the bolts of the cooling oil pipe flange. Mount the eye bolts and lift out the cooling oil pipe. After inspection of the cooling oil pipe, remount the pipe. With the piston standing in the piston support tool, remove the piston rod stuffing box. Lift the piston with a lifting tool, land the piston rod foot on a wooden plank. Note, during the lift, follow with the crane to keep the crane positioned vertically above the lifting point. Lower the piston crown to the platform and land it on a wooden plank so that it is possible to remove the lifting tool. Remove the lifting tool from the piston rod. Attach the lifting bracket to the bottom of the piston rod foot. Hook the crane to the lifting bracket. Lift the piston rod foot clear of the wooden plank. Keep lifting until the piston rod is in a vertical position. Place the piston in an upright position with the piston crown resting on the wooden blocks. Dismount the locking wire and the innermost screws between the rod and the piston crown. Lift the piston rod away and land it in a horizontal position on a couple of wooden planks. Remove the locking wire and the screws in the skirt and mount two eye bolts in the holes intended for dismounting screws. Lift the skirt and land it on a couple of planks. Thoroughly clean and inspect all parts of the piston. Regarding check of the piston crown, replace all sealing rings of the piston. All the new sealing rings must be coated with lubricating oil before the piston is assembled. Coat all screws with molybdenum disulfide. Assemble the piston in the reverse order to disassemble. Use the guide screw to ensure the correct positioning of the piston rod in relation to the piston crown. Tighten all the screws diagonally to the torque recommended. Lock all the screws with locking wire. Mount the locking wire in such a way that the wire is tightened if one of the screws works loose. Fill the piston rod with lubricating oil. Mount the pressure testing tool around the base of the piston rod. Pressure test the piston at the pressure stated of the data sheet. Check the contact surfaces of the piston and the sealing rings for tightness. Check there are no cracks in the piston crown. So that's all for my part. And for the next one is taking crankshaft deflection for diesel engine to be reported by Mr. Escosio.
Good day, everyone. I am Engine Cadet Rainiel P. Iscosio. I will discuss taking crankshaft deflection for diesel engine. Crankshaft deflection. Firstly, how we can define the crankshaft deflection. This is a measurement done on engine crankshaft by placing a dial indicator gauge across the center of the crankshaft webs. While turning the engine clockwise or counterclockwise, the dial indicator deflects the condition by showing both sides vertical and horizontal point readers. The image shows the crank wave deflection. We take crankshaft deflection to make sure the crank runs and maintain proper balance. As we know, the engine crankshaft comprises of the journal, crank pin, and crank webs. These are all supported by the main bearings. Therefore, as the engine runs, due to some friction between the bearings in the crank pin, the bearings wear out and maintain imbalance across the length of the crankshaft. Tools needed. The tools needed is the deflection gauge. The deflection gauge is a dial gauge which measures the distance between the adjacent webs, spread, and different angular position of the shaft. The image shows the how deflection gauge looks like. Next is the crankshaft deflection measurement procedure. Not that we are familiar with the deflection gauge, let's dwell more into detail of crankshaft deflection measurement procedure. There are a few prerequisites that need to be fulfilled prior to taking your measurements, which include the ship should be afloat when taking measurements because the engine temperature can cause variations in measurements. Reading should be always be done when the engine is cooled off. The ship bridge should be notified of the procedure and prevented from turning on the engine. The gauge should be placed opposite the crank pin. And lastly, the mounting position should be marked by a punch mark on the crank web itself. That will be all for my part, and Mr. Diploma will continue the crankshaft deflection measurement procedure.
Okay, good day everyone. I am Engine Cadet Charles Limeldi Diplomo, and I'm here to continue the crankshaft deflection measurement procedure. So to continue, once you've ensured these conditions are met, you can proceed with your measurement as follows. Deflection measurement procedures. 1. Begin with the measurement starting on the bottom port BP position of the crankshaft. 2. Turn the crankshaft clockwise and proceed with taking the measurements for each one of the position noted on the graphic above. Bottom port 30 degrees clockwise from the most bottom position BP. Port P. Top top of the crankshaft TDC. Starboard. To take the measurement for this position, you can use mirror installed on the flexible arm. Bottom starboard BS. Next. 3. Repeat the procedure for each one of the cylinder of the crankshaft. 4. Take note of each measurement in the table below. 5. Calculate the following deflections. B as the average of the bottom port and starboard deflections. The horizontal deflection SP and the vertical deflection TB. Next. This is the example of the crankshaft deflection measurement table. Next. Indications and conditions. Indications. The bearing temperature increases and the damaged bearings. The conditions are ship should be afloat, there should be a calm weather, and the comparison should be made under same temperature and loaded condition. Next. Here are some other procedure in taking the crankcase deflection measurement. 1. Make an enclosed space permit. 2. Stop engine and allow to cool. 3. Block the starting mechanism. 4. Shut off starting air supply. 5. Engage on the turning gear. 6. Open indicator cap because air will compress and give wrong reading on turning the engine. 7. Stop lubrication oil pump. 8. Put tag mean at work. 9. Open crankcase and allow ventilation before entry. Next is this is the other procedure also. Place a dial gauge actually in the crank throw opposite the crank pin. As illustrated on the sketch, the correct mounting position is marked with punch marks on the crank throw. Next. Number 14, the procedure is repeated for each unit and measurements are recorded. The figure is the crankshaft deflection curve. Next. So, next. So there are some reasons for misalignment of the crankshaft. First is the damage or wipeout of the main bearing. Loose engine foundation, bolt leading to vibration. Deformation of ship's hull, crack in the bearing saddle, loose main bearing, bolt leading to damage of main bearing, very high bending moment on the crankshaft due to excessive force from piston assembly, grounding of the ship crankcase, explosion or fire, a defective or worn out stern tube, cracked bid plate deformed, transverse girder damage, tie bolt. Next. So that's all for my part. The next reporter will be Mr. Cyril Filicano.
Good day once again, everyone. I am Engine Cadet Felicano Cyril T. And for the last part of this report, we will be tackling all about the inspection, fitting, as well as replacing our leaking mechanical seal. Um, as we all know, mechanical seals are intended for the prevention of leakages from our machineries of any type of fluid, either water or oil. And in our illustration, we have also have a lube oil pump that is a centrifugal type, and assuming that we have everything under control, we have our PPEs worn already, we have prepared all the necessary papers, especially the risk assessment and work permit. We'll go directly to the disassembly and assembly of our pump. Here we have seen in the screen the flange, which puts pressure onto the spring of the mechanical seal and holds the ports together. Next slide, please. The first thing that we need to do is to remove all the bolts all around the suction flange housing. Next slide. And stripping down a job like this, we need to make sure that all the ports are kept together and all the nuts are put in one container. Next slide, please. We need to leave one nut on the top of the flange cover just to keep it in position till we're ready to take the weight and to remove it. This is a bronze centrifugal pump, and that is why it is really quite heavy. Next slide, please. Next is that we will remove the end cover of the pump. Next slide, please. And the next is the removing of the impeller nut. Behind that impeller, notice a large washer or spacer that just holds the impeller into the end of the shaft. We just need to remove the washer and then, next slide please. And then after we can take off the impeller. It is called a closed impeller because in the center of them are enclosed with a plate. Next slide please. Now we're removing the gland nuts. And along with that gland nuts are the bolts. Next slide, please. Bolts that you see in the screen. We just need to remove all of them and take their brass gland flange off. We just have to roll it and then release the pressure on the spring holding the mechanical seal. Next slide, please. Now, what we're doing next is attaching some lifting lugs on the impeller housing using the studs that are used for holding on the suction flange cover. Next slide, please. And then along with that work, we need to fit the nuts to secure the brackets that we installed. Next slide, please. Next is attaching the overhead crane, and then we just need to give it a couple of knocks through a mallet that helps in releasing the impeller housing, and we need to try not to damage the shaft or bump their housing. After that, we will need to find a safe or inconvenient a convenient place to position that cover while we strip down the mechanical seal and slowly take the weight with the crane. Next slide, please. These are some of the pieces that have just been removed from the pump, and we need to take note on the assembly of the components we pulled out. Next slide, please. And here lies the carbon seal, where it fits in the seal cage, which has a rubber seal in the center of it, so that it's a neat fit over the shaft. It slides tightly over the shaft, just bringing off the gland flange through the ceramic seal. The ceramic part of the seal and the carbon part needed to be handled with great care. If you were to drop them or hit them with a spanner or something, they would shatter and break. Next, we what we're looking at here is a slinger, and most pumps of a slinger attached to the shaft is have a purpose to stop any water leakage that might come out of the pump housing and would make its way down along the shaft to prevent it from entering into the bearing house. Next slide, please. We need to inspect also and clean all the mechanical seals. This is one of the most crucial parts of the procedure. This in here we can have a decision whether we can um, whether our mechanical seals are damaged and are needed to be fit, and if they are not, we they also need a good cleanup before they go back into the place. Next slide, please. So after checking, prepare all the materials needed for installation. And then here you see that is the ceramic seal which has been put after the grand flange. Next, please. And then after that, we will install our new carbon seal and its retainer. We also have to next for the carbon seal is to fit the spring retainer and position it with its locking collar, and then accurately line up the housing with the shaft, and as well as the position of the gland flange on the holding studs. Tighten it up with the bolts, and then remove the lifting glands that we installed a while ago. Fit the impeller and line up with the key on the shaft, and then install the impeller housing and place the bolt nuts. So in behalf of the Group 3, I would like to give a very big thank you for you all viewers, and hope you have learned something new and import it in the near future. Thank you.
Mananabos.